Hi, my name is Manipulate James Noen. This is my final project for ISAP 555. Today I'll be doing my presentation on Andrea sensors and arsenic callback. Now, pretty much what I'll be doing here today is I'm trying to develop an app for a smart device. So there is a procedures that we use in trying to develop the apps. So what we'll be seeing here today is just an introduction, okay? And pretty much this should be my last semester at Mercy College. Now, the second slide will tell you briefly about what I want to do. Before I even go ahead to go into my presentation on the Andrea sensors overview, I would like to first of all give a definition of sensors. One might ask, what is a sensors? A converter that measures a physical quantity and convert it into a signal, which can be read by an observer or by an instrument. Now, we have to understand the word sensors. So what I did was I was trying to do some experimentation, where sensors have been used in cell phones since they were invented. But then the question is, how does it work? So pretty much in my presentation today, I will be touching base on Andrea sensors, mic, camera, temperature, locations, orientation, accelerometer, approximated pressure, and also light. Okay. So the first thing we have to understand here is on the next slide. We will first discuss the arsenic callback. Now, if you look here, I had an app description of where I have the app, and I also have the sensors manager. Now, in between, you will observe the input and the output, how they work, where we have register callback, and then we have a sensor event, and then we have another sensor event, and we have a sensor event. Okay, so pretty much they work in collaboration, with how things work within a system of sensing things out. On the next slide, getting the relevant system service. Okay, in other words, where we set our class, and we have our server set for the public, and we also have the private sensor manager, and then we have the public on create. Okay, so the first thing we want to understand, what I did was in the registering is to obtain a reference to the relevant manager, and in this process we have all the activities get a service method that can be used to obtain a reference to the leader manager. Okay, and this is happening when the signal is sent out, and the sensors detect, and then be able to basically send a feedback. Okay, now let's take one thing into consideration. Not every device has every kinds of sensors. Okay, constants from sensors classes. All right, now we might have a hardware, we might have an acceleration force in the MIS. Okay, but we want to see how this signal is being sent out. So therefore, on the next slide, the first thing I did was to register for a location update. Register for a location update. Now, when we register for the location update, what we observe, we see the acceleration is it's been in place, and actually the acceleration is defined as a rate of change of velocity. Okay, where we have the accelerate meters being measured, and then during that transition, what also we see that the sensors detect movement and corresponding speed rate of change. And the accelerometer do not measure the velocity, okay? But how it works is the prof max shown above is allowed to move in a plane. The attached finger form a capacitor with the two plates around it. The rate of change of the capacitance is measured and translated into acceleration, and that's what happened. Now we're going to go to the next slide. Okay, so we observe that the next slide is a location provider. Now, what is a location provider? The full location can be determined from multiple providers, such as GPS, a network. Now, what happened is, let's say, take for instance, if whenever the update consumes significantly more power than network location update, but are more accurate. Let's take for instance, we had a GPS 25 seconds to which is 140 mA equal to 1 mAh, and then we have the network. We have 2 seconds, which is 180 mA to 0.1 mA. What does that mean? So we basically did what you call the orientation sensors, where you have the combination of magnetic field sensors, which function as the electronic compass, and accelerometers, which determine the pitch and roll. Now, in this process, what happened? Two alternatives for determining the device orientation. We have the query the orientation sensors directly. We have the derive the orientation using the accelerometer and the magnetic field sensors. That is actually basically done on the x-axis. Okay, so what we did was we tried to do some measurement where we took 90 east. The degree isn't enough to see what would be the output. All right, so that we had the location manager equal the get system service location service, okay, and request location update. All right, in order to find the accuracy of the sensors. So let's see the next slide and let's see what happened. So go to the next slide, and we observe that this the location listeners interface. What I mean, in the location listener interface, we have what you call the sensor manager mentors. Now, the sensors get default, which uses mentor to get default sensors. Okay, a list sensors, get sensors. That mentor is used to get the list available sensors of the certain type in this listener interface. Okay, now in the listener interface, we also have the procedures in terms of how the sensors is translate. In other words, how it go out and it also send a message. Okay, and how does that work? So we went on to say that the sensors event parameter in a sensors is charged. It includes for properties used to describe a census event. Okay, now we have the census, we have the accuracies, we have the value, and we have the timestamp. Now, the census itself is a census that tracks the events, and for the accuracies of the census when the event occurred. For the value, it's like a float array that contains a new value detected, and then for the timestamp, we say in nanosecond at which the event occurred. All right, and that's the end of this slide, and that's the end of my project. So we were just trying to basically get what the census is and what method I used to put the app together, and also tested the experiment to get a result from what I was trying to measure. So basically, that's the end of my slide, and I hope this message goes through well. Thank you very much, and have a nice day. Professor Young, I enjoyed this class. Nice, and I hope you teach this class again over and over, because I learned a lot from there. Thank you so much, and have a good night.